Hello. Welcome to math class today, everyone. Aren't you excited? Say yes.
Yes.
We are recording this lesson on Friday, January 14th. And we are talking about our review slide here today. So, here are two numbers. I am not going to read them out loud because I want you to read them with me. Online kids, if you would please stay muted today, unless I call on you being as I'm recording. So, we have two numbers here. Before we read these numbers together, I want to very carefully and gently remind you how we read numbers. This is a very important skill for all people, and all people that I teach can learn this skill. Part of learning a skill is looking at me when I'm talking and listening to me and participating with the class. Yeah? Yeah. Everyone in this room can learn this skill. Everyone in this room needs practice with this skill. So let's remember how we read words. We read the whole entire first part. And then we only say thousand when we see this comma. When you go to 5th and 6th grade, they're going to put another comma in here, right here. And they're going to help you with that. But as a 4th grader, when you see a comma, you only ever say the word thousand. As a 4th grader, you'll learn more about more numbers later. But so you say this whole number and then thousand and then this number. I have people that want to look here and they want to say 5,000, 31,000, 69 and 0. No, that ain't it. Man, that's not it at all, right? Say this whole entire number. Then your comma, when you see a comma, you say thousand. Then you say this next number. Are you ready to read it? I'm not reading it with you. You're on your own. Spread your wings and fly, my little birdlings, little tweetlings. Ready? Here we go. Go.
531,006.
Okay, stop. We're not all going together. Some people are trying to talk too fast to get to the finish line first, as if there's some kind of prize or something. There's not. There's no prize. I want you all to stay together and to do this as a family. Okay, can we try it again? Here we go. Ready, set, go.
531,690.
Excellent. 531,690. Very good. And the other one? Go.
58,487.
Woof. Rough. We read this whole piece. When we see the comma, we say thousand. And then we read this whole piece. Are you ready? Let's do it again.
58,487.
Very good. 58,487. Now, the question is asking you to write this first number in expanded form. Yesterday, I gave you 2 different strategies to do that. We talked about plugging this number into the place value chart. And so we would take this number and put it in here like this. This last number always has to land in the ones place. This digit here, whatever is last in the number, always has to land in the ones place. That's how you know whether you got your number in the right digits or not. Okay? You always have to land in the ones place. So we can use a place value chart. And when we do that, we can see that the 5 hits in the what place? Hundred thousands place. So we have 500,000 plus,
30,000.
right? Because we have 3 tens, which is code for 30. Good. 30, but it's not just 30, it's 30,000 plus 1,000. Oh, look at you guys. You guys are doing it. 600, almost, plus 90. Very good. That is one good way that we can accomplish this using our place value chart. Now, I gave you another strategy to accomplish this here yesterday. You're going to take each one of these digits, and as long as it has something that's more than nothing, you're going to take this 5, and then for each digit that follows, you're going to follow that 5 with zeros. So 5, 1, 2, 3, 4, 5 zeros. Plus 3, 1, 2, 3, 4 zeros. 1, 2, 3, 4 plus, oh man, come on. Come on, man. 1 plus 1. Oh, that's not right. 1. Yike. Okay, got it. 1,000. Then we have a 6. How many digits follow the 6? 2. So we're going to follow the 6 with 2 what? Zeros. Because that tells us the place, the value of the 6. And then we have 9. How many digits follow the 9? 1. So we know that's 90. Now this 0 has a 0 here. What do we do with the 0? Nothing, because 0 is code for nothing. So do we have to write nothing? No, it's just 0. It's just nothing. So we just don't write anything, right? Right. Okay. Write the first number in expanded form. Got it. Oh, one more thing I want to tell you, and I'm recording. I've told all the other classes today. I want to make sure I get it on tape. When you check your work, so, hi students. Hi. When you take a test or you're doing any kind of work in a notebook or in a workbook or in whatever other kind of math life you live, right? Are you just going to plug in the answer and then just, skip on to the next question? Or are you going to check your work? We're going to check our work, right? You're going to make me and all the other math teachers in your life very happy if you will go back and check your work. How do you check your work with this? Oh, I'm glad you asked. Let me teach you. Are you ready? Here it comes. These things here, this and this and this and this and this, these are called addends. An addend is any number that you add with another number to get a sum. Thank you. So every addition problem has at least 2 addends. The way you know if you have everything you need is by saying to yourself, how many digits in this number have something more than nothing? How many digits are not 0? So you have 1, 2, 3, 4, 5. That means you need to have 5 addends. 1, 2, 3, 4, 5. You might not be completely right, but at least if you have 5 addends, you know you're on the right track. That's a good way to check your work. How many digits, because this is a 5, 3, 1, 6, 9. The 0 doesn't count because it's nothing. So we're not going to worry about that 0 when we're checking our work. I don't need anything for that 0. So if I did this number, how many addends would I be looking for? Tucker?
3.
3. And what's the value of this 6 here?
600,000.
600,000 plus
8,000.
8,000 plus
70.
70. These are zeros. We don't have to write anything for them. We're looking for 1, 2, 3 add-ins here. Does that make sense?
Yes.
That's all for checking your work. That's just a little bonus, not in my notes. You get that part for free. Okay? Now, what is the value of each 5? Dominic.
For the first one, it is 500,000.
500,000 for the first one. Who agrees with Dominic? Hands all over town. Thumbs up too. Excellent. And the second one? 50,000. Very nice. This one is 50,000. Hands if you agree. I kind of told you that you should agree when I said very nice. That's code for yes. Good job. Okie dokie. Good job. All right. Our lesson today, it's a good one. I like it. So I told the first class, I think I forgot to tell the second class, but I'll tell you. This concept, as this is my 6th year as a math teacher, I've taught math my whole teaching career. This concept in math is one of the most difficult for me to teach. I don't know why, but it's a challenge. Here's what I found today is that if you're in my class and you've been following my videos and my lessons, whether in person or online, you have already been doing this and you don't even know it. Which means today is going to be an easy day for you. Are you ready for an easy day?
Yeah.
Let's write equations to show the relationship between the digits in multi-digit numbers, shall we?
Yes, we shall.
That's like my favorite part of every class. Yes, we shall. Before we do this, shall we do a number talk?
Yes.
Don't jump ahead of me on the number talk, you little number talk jumpers.
I did it.
Find the value of each expression mentally. No paper, no pencil, no fingers. Just your brains, your big brains. Brain challenge. Here we go. Raise your hand when you have an answer. Logan?
So you first
Just give me an answer.
700
Not and.
700.
You're doing it.
15.
Oh, close.
5. 20. 720. 5.
$725. Bobby, help him finish it. 725. Was he wrong?
No.
No, he just said and. He just said and. Next. Sit down. Sit down now, please. Sit down. Gracie.
5,725. Not and. I didn't say and.
You can't say in either. You can't say and or in. 5,725. Good job. Ready for the next one?
Yes.
Brentley.
50,725.
Good. You ready for the next one?
Yes.
No.
Everybody say it together.
500,725.
Whoa, I expected that to be a lot more smooth than it was. Say that answer together again.
500,725.
Which parts of the number change when we add 75? Which part of the number change when we add 75? I recommend you looking at the purple to start the answer to this question. Cole?
It went up 5,000 the first time.
No. Just look up here. When we add 75, which part of this number changes?
The hundreds place.
And? The hundred, the tens, and the ones. When we add 75 here, the hundreds and the tens and the ones all change. How do we know without adding if digits in a number are going to change? So in this number, they all change. Before Logan got his answer, he knew that was going to happen. He could see it coming, right? How did he see it coming? What did he see? How did he know? Why did he go so slow? Because he was adding up really slow, and then as he was going, he had a realization. Bobby, talk to me about that.
Because when he was doing it, he was just adding on top of it a different way than and then probably figured it. And then because all you have to do is add it. So, well, you just have to.
Let's think about this question again. Let's think about it deeply. How do we know without adding if digits in a number are going to change? Cameron?
Because there's different numbers.
There are different numbers. Tucker?
So there's a plus sign, so that means it's definitely going to have to change.
Something's going to have to change. But look what happens here in the pink. Now we have 5,650. But the 5 in the digits in the tens, yikes. The 5 in the thousands place didn't change. Why is that? What's going on with these digits in these places that some of the digits are changing and some of them aren't? Because then look and see what happens. Then we get down here and we have 2 places that stay the same. We have 3 places that stay the same. What's going on here? Talk to me, Trenton.
It's because there's simply not enough to just add to make those ones change. Like if you're adding 75, that's definitely not going to change like 5,000 if it's only to 650.
Okay. So we know we don't have enough to change those all the way there, right? We know we don't have enough to change those all the way there. And so we can know that that's why it's so easy to think, okay, this one's 725. This one's going to be 5,007. You know what I mean? This one's going to be 50,725. That is the deal. Very good. In your notebook, those of you that are online, please participate. I want you to draw this chart. Not a hard chart to draw. It's just 2 columns. In the classwork section, I'm going to explain everything you need to know. They're in the classwork section of your notebook. Draw this chart. Fill in all the information they give you, and then do what you can to fill in the blank spaces.
Okay.
Yes, Izzy? You have a question? No? Okay. Fill in all of the piece of the table that you have, and then fill in stuff that they want you to have. Those of you online or watching via video, the same amount of time I'm taking to give these kids in class to do this, you should be doing this too. And don't write words, write numbers. In the section that's not has anything, write numbers, not words.
All right, what's the word? Add.
You're supposed to put the value of the 8 in this number. What's the value of the 8?
I'm supposed to put the number in.
Not the words, the numbers. You're right, but I want you to write numbers. It's okay. Just keep writing your words. All your words are correct. It's okay. It's okay. Who wants answers? Who wants to check their work? All right. I'm looking around, and the stuff here in class looks good. The people that are working in class looks really good. That's right. Good job. Yeah, we're doing good. What's going on here? You're stalling. That's what stalling is. I'm going to write really slow so I can just wait until she writes the answer up there. Don't do that. Answers in class are looking good. Here they are. Yes. 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 Yes.
Yes.
I did it. Yes.
That was really easy.
Oh, wait a second. Hold on. Hold on, JC. Say that louder.
That was really easy.
That was really easy. Like, come on, lady. Don't you got anything harder for us? That was so easy. Fine. You want something harder?
Yeah.
I got you.
Yeah. No, not really.
I love you guys. Do you love me back? Please say yes.
Yeah.
All right. Describe the relationship between the value of the 8 in each number, little Miss Easy Pants. So, JC says, it's so easy. Okay. Let's kick it up a notch. Describe the relationship. So when we talk about relationships, we've talked about relationships in numbers before. We've done this. Right? We've talked about relationships before. We've talked about relationships in other ways. We've talked about this. Right? We talked about this. Right? These are relationships in numbers. All these numbers are a part of some sort of family somewhere. They're related. They either work together to make another number, or they can like come from that number. Okay? They have a relationship. They're related somehow. Talk to me about, I want you to pick numbers that are side by side. So either 8 and 80, 80 and 100, 808,000, or 8,000 and 80,000. Pick two numbers that are next door to each other. How do you think those numbers are related? How are they related? Annabelle has been sitting very patiently waiting with her hand up for 1 second, but I'm going to pause on you a second because Landon has his hand up, and I want to hear what Landon has to say, and then Annabelle, you're next. Landon, what do you think? Thank you for raising your hand.
They all have 8.
Is he right?
And zeros.
Uh-oh. Do they all have zeros?
No, not 8.
Not the last one, but a lot of them have zeros. Okay, Annabelle, what were you going to say?
I noticed that from the top, from the bottom, I noticed that the 8s, every time it's going down.
What do you mean going down?
8, like 10,000 and it's 1,000, 100.
I don't have a place value chart on here.
Then 10s and then.
Annabelle says every time it's going down, and Trenton's like every time it's losing a zero, you two are saying the same exact thing because you're talking about going down the place value chart from the thousands area all the way down to the ones area, right? And when it does that, every time it does that, it loses a zero. Excellent. Excellent. Excellent relationships. Now, can we kick it up another notch?
Yeah.
Can we? Whoa, somebody's excited. Good. Yeah, me too. Can we write a multiplication or division equation? So can we use multiplication or division to represent the relationship between the values of the 8s and two different numbers in the table? That's a lot of words to say. Can you times or divide to get from here to here or from here to here? And how would you do that? What would it look like? I want to give you 1 minute of think time. I want you to think silently for one whole entire minute. People online are excited. They're like, I want to answer. 1 minute of think time. Think. I know. Hold on.
Break the chair.
12 seconds. What thoughts do you want to share? Jaden. Over here? It's divide. It's not minus. It's okay.
I was looking at the 80 and the 7, and I decided that if you take away the 0 from the 80 and then replace it with the 8, it'll be 80.
Okay. Let's take the first half of Jaden's thought. If we start with the 80 and we take away the 0, it'll be the same as 8. And is she right that if we put these two together, that's going to give us 88? She's right. We're not talking about addition, but you're right. Let's talk about this 80 and taking away the 8. Tucker?
I just noticed something else. It's just, like...
Okay, pause your something else. I want to finish Jaden's thought before we jump into another thought. Emma?
You could do
So over here, we could do 8 times 10 equals 80. And if we're going to talk about how these things are related, what can I do with these same three numbers over here? Gabe?
You can do 80 divided by 10 equals 8.
Yeah.
Yeah.
Yeah,
Or
you
the
can.
Other way around, like.
Yeah, because those digits, those numbers are related.
Basically,
Go.
Division is basically backwards multiplication.
Basically.
Yeah.
Yes, pretty much. If you could learn that, if all my students can learn that, I would be thrilled. So what else do you want to put on this chart now that we have an idea of what we're doing here? Gracie?
1,000 divided by 10 equals
80,000
8,000.
divided by 10 equals 8,000. Is she right?
Yeah.
So here's what we're doing. We're taking this number, putting it into groups of 10, and then there are 8,000 in each group. Let's do another multiplication. Who can put one up here? Bobby?
And do 80 times 10. Equals 800.
Oh. Is he right? You sure he's right? Or are you just saying yes because you think because I wrote it? Would I ever write the wrong thing on purpose to try to trick you?
Yeah.
Would I try to trick? Would it be me trying to trick you or me trying to train you to see the tricks? Training, right? I'm not being rude or unkind. I am trying to teach you. Yeah, you know what I'm saying? What else do you want to write? What else do you want up here, Tucker?
I just noticed something. The multiplication is going higher and the division is going down.
Yeah,
I mean,
exactly right. Bobby, we already got 80 divided. We need 800.
800 divided 10 equals
Good. Who else wants to put something up here? Come on, people. I got only like 2 people in here raising their hands. I only got 2 people in here. Logan.
5 times.
No 5s up here, my dude.
What? Wait, so 8,000 times 8 equals 80,000.
Not times 8.
8,000 times.
So let's talk about.
800.
Nope. Let's talk about this. Are you ready? Are you ready? If I have 8 ones, y'all see my 8 ones? What do I hold in my hand? What's the value of what I hold in my hand? 8. If I change all of these little ones, if I multiply all of these little ones times 10, that's going to give me, really? That's going to give me 80. That gives me 8 tens, right? If I multiply these 8 tens times 10, that's going to give me 800. If I multiply all these 800 times 10, that's going to get me 8,000 because each of these is 1,000. And so I would have 8,000. What are we always multiplying by? We're always multiplying by 10.
10.
Do you remember the name of our lesson today? 10 times as much. So, Logan, what are we multiplying by?
80. We just said
Nope.
no. 800.
It's unkind.
800.
No, well, we have, let's do here, 800 times, everyone, 10 equals
8,000.
8,000. 8,000 times 10 equals
800.
80,000, because we're going, like Trenton was saying, we're going from the 1,000s place to the 10,000s place, from 8 to 80. And then, this isn't on our chart, but 80,000 times 10 is going to equal 800,000. Good. And then the same here is for the division. This side here is going up the chart. We're starting at 8. We're going to 80, and then 800, and then 8,000. This here is going down the chart. 80,000 to 8,000, 88, and 8, right? Does that make sense? All right. Today we wrote multiplication and division equations to represent the relationship between the digits in different places in multi-digit numbers. I want you to take another 1 minute. Decide which one of these are true or false. That's it. Just true or false. Just leave this one. Okay.
One draw division and one draw multiplication.
I don't know. True or false? Which ones are true? Which ones are false? 15 more thinking seconds. All right. Letter A, true or false? Everyone.
False.
False. If we have a 2,000 times 10, is our number ever going to be smaller? No, that makes no sense. Letter B, true or false?
True.
True. Because when we have 2,000, we're going up 10, which each time we move from here to here to here to the box is 10, right? So that's, oh,
I was going to tell you that.
true. Sorry. Letter C, true or false?
True.
Also true, because look here. Do you see a relationship here?
Yes.
This one's in front ways and this one's in back ways. Letter D, true or false? True. Good. And letter E, true or false?
False.
False, because we're only going down 10, but here we went down like 1,000, didn't we?
Yeah, we went out 1,000 with that.
Yeah. We went down like 1,000. All right, this concludes our math lesson for today. You all did a great job. I'm going to stop this recording for my class and then answer any questions you may have before the weekend. Thank you all for joining me. We're going to stop.